everybody. This is Suvarchala, working as an associate professor in the Department of Computer Science. It's a part of the Database Management System lecture series. In this lecture, I would like to discuss about the recovery algorithms related to buffer management actually. In previous lecture, already we discussed about recovery management techniques and what are the transaction failure types or what are the various failure classification were discussed and how recovery can be applied. Recovery algorithms are going to be applied, techniques are going to be, or strategies are going to be applied to get back our data during the transaction processing. Specifically, when the transactions are supported concurrently, then are processed concurrently, then this recovery process is very, very useful to us actually. So the basics of this recovery algorithms were discussed in the previous lecture. Now we'll discuss about the recovery algorithms based upon our redo and undo operations. As we discussed earlier, the recovery algorithms are going to be considered when if any failure occurs to recover data from the transactions which are already completed or which are under processing or which are aborted. This entire data can be recovered based upon the specific failure. Two atomic processes are going to be used by us, that is redo operation and undo operation. By using these two operations, the data which is already transactions which are already completed, committed, those are going to be redone. The transactions which are under processing, still not yet completed, those are going to be undone, partially executed transactions. For that purpose, we discussed already, log records are going to be maintained and these log records are going to be stored in a stable storage. So failure of the log records are very, very rarely occurs. During the normal process, log records are going to be managed like this. TI start at the transaction time of starting, this log record is going to be written, and TI xj v1 v2. That is, in the attribute xj, v1 is the old value, v2 is the updated value. For each update, this log record is going to be written. Remember that whenever the data is updated, the updations are taking place in your buffer block. And when the TI commit is there at transaction end, these are the various kinds of log records are going to be used in our log file. During the normal operations, transactions are going to be rolled back. The reasons may be anything actually. The transactions are going to be rolled back means here, whenever the transaction is going to be get aborted due to concurrency schemes, etc., or any other, because of any other reason, then the respective transactions have to be rolled back. Rolled back means old data are initially, before transaction starts, what is the status of the database, that status must be maintained by us to avoid the inconsistency. So that's why the transaction rollbacks are during the normal operations. Any TI be the transaction to be rolled back, scan all log records in the backward direction from the end, and for each log record of the updations which we are having, TI xj v1 v2 is replaced with TI xj with v1 with old value. Rolled back means with old status, no? So v1 is old value, v2 is the updated value of xj. So when we are rolled back, the respective old data is going to be indicated for that particular attribute actually. So whenever we are using such type of performance, the undo operations are going to be performed by writing v1 to xj, and such log records are called as compensation log records. That means when abort we are making rollbacks, additional log records are added. These records are known as compensation log records actually. Once the record TI starts is found, stop the scanning and write the log records as a TI abort. That means we are starting from the end now and we will move upward direction till all log records which are having TI, for all of them this process is considered. When we reach TI start, the process is going to be stopped. That means after once this process stopped means our TI is rolled back means aborted. So that's why TI abort is written into the log record actually. Sometimes what happens, we have to recover it from failure also. So if you want to recover from failure, there are two phases, redo phase and undo phase. These redo phase undergoes an atomic algorithm, redo algorithm, and undo phase undergoes an atomic algorithm, undo. What these algorithms are going to be specified, or what this phase, under this phase, what happens? Under redo phase, replay updates of all transactions. That means rewrite all attributes with new values, whether they are committed, aborted, or incomplete. In case of undo operations, undo all incomplete transaction. Redo is for all complete transaction, that is committed transaction, or aborted transactions, or incomplete. Undo operation is the all incomplete operations are going to be undone. So redo phase means how it works actually, recovery algorithm. First find the checkpoint, the last checkpoint L record and send undo list to the L. Whenever we are considering this last one, redo phase consists of because we discussed already what is checkpoint. Checkpoint means whenever recovery takes place, quite a long period of time our system is working, all transactions, multiple transactions, sometimes thousands of transactions might have been completed. All these transactions have to be redone again. To avoid this process, once it is permanently written into the secondary storage device, this redo phase will consider up to the checkpoint only. So we will put checkpoints in between so that up to checkpoint only recovery will be considered. Before checkpoint, the transactions which are partially included are going to be considered, which are completely included. Those are not considered to recovery because all of them are already permanently written our secondary storage section. So that's why how the redo phase works. This redo phase works first to find the last checkpoint. From that only any process has to be considered. Then set undo list to L. We will find out at the time of redo itself, we will find whether what are the transactions have to be undone afterwards. So which transactions have to be undone? The transactions which are started but not completed, those must be undone. That is TI start is available, but TI commit or TI abort is not there, then that is included in our undo list. Again, need not check again for at the time of undo list actually. So scan forward from the above checkpoint record. Forward from the checkpoint record, whether a record TIXJV1 V2 or TIXJ V2 is found, redo it by V2 to XJ. That is write new value. Whether a log record TI start is found, add TI to undo list. Whether log record TI commit or a TI abort is found, remove TI from the undo list. That means when start is there, initially we are thinking of all transactions after checkpoint are not completed. So that's why whenever start occurs, it is included in our undo list. But what happens then? Whenever a commit or abort comes means this is completed, no? So redo is enough for us. Undo list not can. Then what is the content of our undo list now? Only the transactions which are started but not completed. But not completed means but not committed or aborted. Those transactions are going to be undone from this undo list actually. So what is the undo phase will take care of? In case of undo, scan logs backward from the end. Last log record onwards, scanning is going to be done in backward direction. Already list is available to know. So whether a log record TI, XJ, V1, V2 is found, whether TI is in the undo list. If TI is undo list, then only we have to do. Otherwise, no need. What we have to undone means write the value, old value into the variable. So that's why if the respective transaction is in the undo list, perform the same actions as per the transactions are rollbacks. That means what are the rollbacks means? We have to add, we have to fill our variable with the old value. Perform undo by writing V1 to XJ. Write a log record TI XJ V1. For recovery only we have done the same thing, no? And whenever a log record TI start is found, whether TI is in undo list, then write the log record TI abort. That means we aborted, no? Undone, no? That's why we can include a TI abort and remove the TI from the undo list. This process is continued for all transactions in the undo list. Stop when the undo list is empty. That is, TI start has been found for every transaction in the undo list. After undo phase completed, then normal transaction processing can be commenced. What does it mean? That the recovery process, during the recovery process, no other transactions are allowed. Please note that. Whenever the recovery process is going on, our system is going to be temporarily suspended, and once it is recovered, then the transaction processing is going to be continued. So this is an example of recovery, beginning of the log. You observe here. Now we have two transactions. T0 is one transaction, T1 is another transaction, T2 is another transaction. So T0, T1, T2. And checkpoint. So you observe, where is the checkpoint? This is the checkpoint. So when we are doing this, this is the log, end of the log, crashes occur here. Let us assume that. Crash occurred here. Then what I supposed to do? In case of we have to first consider from the checkpoint start T1, right? T1 commit is there and T2 start is there, T2 updation is there, T0 abort is there. These are the things we are having. So when we are getting here, older one, these are the older and these are the newer things. Before checkpoint are older and after checkpoint we are getting whatever the after abortion we are writing, no. So this is the recovery. During the recovery process, whatever we are writing, those are newer things actually. Redo phase is going to be done, undo phase is going to be done first. Now if you observe here, T0 is aborted here. That is, T0 is going to be rolled back during the normal operation begins itself. So T0 rolled back already completely rolled back actually. We need not do anything with T0. Because T0 abort occurred, T0 start is there, means it's already rolled back, no? No need to redone again actually. Now you observe here, T1 started, but T1 is committed. So here T1 is also started, T1 committed means T0 is aborted, rolled back already. T1 is committed, completed. Understand? So while doing this process, redo process, then T0 is going to be having, T0 start is there before and T0 commit abort is there. When this T0 abort is there, then from initially it is in the undo list and T0 is going to be removed from the undo list, T0 abort. T1 is also having start and abort. So then, commit. So T1 is also completed. So T1 is also not included in our undo list. So redo process, we are starting from here. Whenever we are getting here abort or commit means those are completed or rolled back. No need to include our redo list. Undo list. But coming to the T2, here after checkpoint when I am coming, T2 start is there, then I am including in undo list as a T2. But till end T2 abort or a complete commit is not encountered. It is still there. So please observe T1 is first initially, T naught is there, but when T naught abort comes, this is removed. When T1 commit comes, this is removed from the undo list. But T2 start is there, it is included and it is there still because T2 commit was not at all encountered. So in case of undo pass, what we supposed to consider? We have to undo only T2 list only, T2 transaction only. So T2 must be rolled back in the undo phase. Start log records found for all transactions in the undo list. Now in the current example, only records related to T2, those have to be undone. So when we are moving upward direction, T2 A 500 400 is there. What is old value? 500. So A will consist of 500 and T2 start. It's okay. After completion of this, T2 A 500 is there. T2 after completion of this undone process, it is rolled back now. So that's why T2 abort is added. These two are the new log records added during the recovery process actually. So like this we are going to consider whenever the process is going to be added or deleted and the transactions which are completed, those are going to be redone, or aborted, those are going to be redone, and the transactions which are not completed, those are going to be undone actually. So this process is going to be considered here whenever we are having the respective transactions are executed based upon the records are going to be maintained. How these log records are going to be stored, where it is going to be stored, how the log records are going to be buffered. That means again get back to our buffers. Those are going to be manageable by using our log record buffering system. Log records are buffered in main memory instead of being output directly to the stable storage every time. These log records are output to the stable storage when a block of log records in the buffer is full. We will call it as a log force operation. Log force operation means there is no space to store our log records further in buffer. Forcibly, we will move to the stable storage, the entire log block actually. Till entire log records are going to be moved to the stable storage, no process is going to be considered by us. Because additional log records have to be stored, no, by that time this log buffer must be get emptied. This log force is performed to commit the transactions by forcing all its log records, including commit record, to the stable storage. Several log records can be output using the single output operation so that the reducing the IO cost. Because all are stored in a buffer, no, a block like that. So that's why with one input or one output operation we are performing, no. So because of that, what happens? Then the IO cost is going to be reduced. That means here, whichever the log records we are maintaining, all log records are going to be initially the buffer only. When the buffer is full, then only forcibly it will be returned into the stable storage. So when the log records are stored in a buffer, these are the rules we will follow. Log records are output to stable storage in the order in which they are created in our buffer. Same order should not be get changed. And transaction Ti enters into the commit state only when the log record Ti commit has been output to the stable storage. What does it mean? That whenever any transaction commits, then automatically up to that the all log records must be transferred to our stable storage, permanent storage. Remember that. Then only the transaction is going to be committed. If it is still buffer, because anytime power may get failed, no, so then automatically you may lose some log records also. So that's why to avoid that, when any transaction commit is considered to be as a committed completely when the log records are also output to our stable storage. Before block of data in main memory is output to the database, all log records pertaining to the data in the block must have to be output to the stable storage. Another rule. That means, as we discussed earlier, the block of data is going to be transferred from between our main memory to secondary storage memory. So, as we discussed, some of the updates are done on our main memory only in the buffer, but it will be transferred to, when it is get committed, it must be transferred to our secondary storage also. So these log records are going to be, block of memory is transferred to the secondary storage means all log records related to this block must be transferred to the stable storage. This rule is also called as a write ahead logging. Write ahead wall. Wall rule means the write ahead logging. Write ahead logging means before transferring your block, the related log record must be transferred to our entire stable storage actually. So, this database buffering is one of the concepts in which the IO cost is going to be reduced based upon the buffer size and block size. This database maintains an in-memory buffer of data blocks. So frequently used blocks are going to be transferred. No, those are going to be kept like that only. There are various techniques are there actually. Which block has to be sent back to the database again. Which block has to be keep in your buffer main memory. All these some algorithms are there. Some techniques are there for that. When a new block is needed, if the buffer is full, an existing blocks need to be removed from the buffer. But which block has to be removed? Some rules and regulations, some algorithms are there actually. If the block is chosen from the removal has been updated, it must be output to the disk. If it is already have some updations, output. Then automatically the respective log records are also first written into our stable storage. So that's why the recovery algorithm supports the no force policy, that is update not entire block. No need to rewrite entire block. No. So that's why only the updated data is going to be written back. Why all? Because the data which is undergone only read purpose, entire block may not be updated, no, generally. So if it is updated, it's okay, it will be entire block is going to be transferred. So instead of transferring the entire block to rewrite on our respective block place, instead of rewriting everything, only the data which has been got updated, that data is going to be stored or updated in our secondary storage device. We will call it as a no force policy. Force policy means here requires updated blocks to be written at a commit. Whenever a commit occurs, even it need not wait till the buffer full or not. If we discussed earlier also in the previous slide also, when transaction commits, it must be written permanently into the secondary storage device. But this is known as a more expensive commit. That is, we will consider as a force policy means expensive commit is there. Because for each commit, that block has to be rewriting into the secondary storage device. And this recovery algorithm supports one more policy known as a steal policy. What is this steal policy? Blocks containing updates of uncommitted, because we are committed data only we are writing, no? Instead of that, even uncommitted updates are there. Those are also going to be uncommitted transactions updates are there, no? Those are also going to be written to the disk even before transaction commits. That is known as a steal policy. What is meant by steal policy? The blocks, set of blocks are containing updating of uncommitted transactions can be returned to the disk even before transactions are going to be committed. So that's why if a block with uncommitted updates is output to the disk, the log records with the undo information for the updates are output to the logs on the stable storage first. Because wall has to be supported, no, writing ahead logging, no. Whenever we are writing a block into the, we are updating whether it is committed or uncommitted. For example, if you even uncommitted, if you are rewriting the updated data into the block secondary storage device, then it must be related logs must be returned first to the stable storage. No update should be in the progress on a block when it is output to the disk. So how to ensure it actually? No update should be progress on a block when it is output to the disk. How to ensure means the process has to be stopped or it's suspended. Before writing a data item, the transaction acquires exclude. That's why how to ensure it? Because the block is writing from buffer to the disk. During that period also some of the transactions may be need some data. But we should not provide data because it is under the process of updating in secondary storage device. It must be ensured that during the updations, no other transaction uses the respective data. How to ensure that? We will put an exclusive lock on that particular block. Once you are acquiring an exclusive lock on the block means no other transaction will get any of the lock from that particular block of the data. So the locks, that means it's not a part of the transaction processing. Only while doing this copying of our updations are going to be carried out in the secondary storage device from the buffer. During this process only, we are doing this kind of, we are acquiring these kind of locks. Acquiring the locks during such type of such type of periods is known as latches. That is the locks which are held for a short duration, that too for the purpose of our data transfer from between buffer and secondary storage device are called latches. Short period of time. It's not by the transaction supported by or submitted by the user group. It is only during the process of our data transfer from buffer to database as well as database to buffer. So these are the steps we will follow, which we explained just now, to output a block to the disk. Whenever from the buffer the block is going to be outputted to disk, what we supposed to do first? It should not be allotted to any other transaction. So for that purpose, first acquire an exclusive latch on the block. We will call it as a latch, I told you. It's nothing but just like an exclusive lock. Then ensure no update can be progress on the block. At that time, current process, any updation is not going on. Then perform log flush. Log flush means all log details, log records must be transferred to your stable storage. Then output block to the disk. Finally, release the latch on the block. Once it is outputted, you can release the. These are all based upon the database buffering. Database buffer can be implemented either by using an area in the real main memory reserved for the database or virtual memory also. As in case of other buffering processing, here also these buffers can be from main memory or buffers can also be from the virtual memory, which is supported by the respective operating systems actually. So while doing this recovery process, as we discussed earlier, instead of applying this recovery for entire transaction data which has been done from the previous last failed or failure, instead of doing many times the same thing, repeating the same updations, etc., to avoid that, we will use these checkpoints. Our log records are of the two types actually. We already have seen that. One is the transaction records, another kind is system records. Transaction records consists of the transaction ID and other operations, that is begin or insert or a delete or update or a commit related data. But system records consist of the checkpoints and dump. What is the purpose of checkpoint? The goal of the checkpoint is to register in the logs so that the set of active transactions T1 to Tn or differentiate them from the committed transactions already committed. Every time, whenever recovery occurs, again do the same. Why? Because already it has been written in the secondary storage device also. In such cases, why should we consider all these things? So that's why checkpoints are going to be used to reduce our recovery process, reduce the recovery process on number of transactions. So the checkpoints operation is executed periodically with the fixed frequency, depending upon our transaction load or a transaction processing load in our database systems. For example, in any real-time banking application, multiple updations are going on, no? Every second, multiple updations are there. So that's why to avoid this recovery, repeated recoveryness, period frequency of introducing this checkpoint frequency is going to be very, very high. And the updations are not much. For example, any college information system, if you are taking, no, may not be more updations daily, no? So the period may be weekly ones are like that, checkpoints are daily ones like that. But in case of real-time transactions like banking, etc., you may put checkpoints after every 6 hours or 3 hours, etc. also. So that the redoing of the same operations multiple times can be avoided if any failure occurs during the recovery process. Another word which we are going to use is dump. Dump means it is a copy of the entire state of the database. Generally, we will take dump any problem occurs where the problem occurred. We will take dump from that is memory dump, like that we will consider. Memory dump means the entire memory scanning will be taken as a printout, and we will check any problem occurs in the memory while doing any process. We can do that one actually. So that here dump is a copy of the entire state of the database. This dump operation is executed offline. Offline means all transactions are going to be suspended. Just like a backup, you can say. Dump means taking a backup like that. It produces a backup. That is, the database is saved in a stable storage. Like RAID or any stable storage, it can be stored. It writes forcibly a dump record in the log. In the log also, a dump record is going to be represented. So it writes a dump record in a log. That means we are able to understand up to that position dump was there, copy was there. So any recovery is there, then entire dump is as it is. From there onwards, again the remaining process can be considered for the recovery actually. So there is a slight difference between checkpoint and dump. Dump is a copy is available, it will be as it is. After a dump, any process have been made, any transactions have been, on those transactions only these recovery techniques are applicable, either redo or undo or both, whatever. Checkpoint means already log records are there. From the checkpoint onwards, these redo undo operations are going to be carried out in the log records actually. So for example, here a dump is there initially, then transaction T1 begin, transaction T2 begin, checkpoint are there, then some operations have been performed, a crash occurs, then from this checkpoint onwards, the entire recovery is going to be considered. But before that, the data corrupted means from the dump it will be taken, from there onwards the recovery process is going to be considered. To avoid the long interruption of normal processing during the checkpointing, we can allow the updates to happen during the checkpoints. That is, during the checkpointing also, updates are going to be considered by using fuzzy checkpointing technique actually. What is this fuzzy checkpoint technique? Temporarily stop all updates by the transactions and write a checkpoint L log record and force log to stable storage. All transactions are stopped at that time and a new checkpoint was returned, and all log records are also forced to write in our stable storage. Then note the list M of the modified buffer blocks, and then we are going to consider the respective permit transactions are going to be, whatever the transactions are there already going on, those are going to be permitted to proceed their actions. So during the checkpoint, a little transaction processing is going to be suspended for a while actually. List of M of modified buffer blocks. We will note down the all modified buffer blocks are noted. Then we will start the transaction is going to be processed. Then output the disk all modified buffer blocks in the list M. Block should not be updated while being the outputted. Remember that. Follow wall rule. Wall rule means you have to, before updating our output into the secondary storage device, log records must be written into the stable storage. That is, all log records are pertaining to the block must be output before the block is going to be outputted to the secondary storage. Then store a pointer to the checkpoint record in a fixed position, last checkpoint on a disk. By using this fuzzy checkpointing, recovery is considered, start scan from the checkpoint record pointed by the last checkpoint. Then the log records before last checkpoints have their updates reflected in the database already, no? So we need not consider them. We need not read on them because during the fuzzy checkpointing only after that we have already updated blocks are transferred. Updated logs are going to be transferred. Already everything has been done. Then the transaction started. So that's why whenever recovery process is there, up to that has been permanently written in secondary storage device. Those need not be redone. The incomplete checkpoints where the system had crashed while performing the checkpoint are handled safely by, that is the last checkpoint onwards only we have to read on ourselves. Sometimes what happens, the failures may be because of the loss, the data loss, or a failure may be there because of non-volatile storage also. That is disk failure, etc. Till now, what type of failures we addressed? We addressed only non-volatile storage. As far we assumed no loss of non-volatile storage. Till now, we are worrying about only volatile storage data, that is buffering and failure in our system only. But sometimes what happens, there may be failure in our secondary storage device also. So if any failure occurs in the secondary storage device, that is non-volatile storages, what happens? Various techniques are similar to checkpointing are used to deal with the loss of non-volatile storage also. Because periodically dump will be taken, entire content of the database is going to be transferred to some stable storages, or backups are going to be taken. During these backups, no transactions are allowed, and output all log records currently residing in the main memory also onto the stable storage, output all buffers blocks to the disks, copy the content of the database to the stable storage, and output the record dump to the log record. Whatever we have done in fuzziness, no, similar fuzzy checkpoint, similar to that only. So that's why to recover the data from this non-volatile storage, dump is going to be considered. How the process of dump is considered? Periodically dump is going to be done an entire content of the database. During this process of dumping, that is taking backup, no transactions are allowed. So what it will do, first before taking any dump, all log records are going to be currently reside in our main memory must be sent back to the stable storage, and all contents of the database buffers blocks must be sent out or output to the disk. Then enter send an output record dump to the log record and the stable storage also. Then start taking the backup. That means up to that were updated both in our database as well as our log basis also. So that's why in such cases, if any failure occurs, to recover from the disk failure, restore the data from the most recent dump, because backup is there now up to that. And from there onwards, whatever the log records are available in our memory, consult the log file, redo the all transactions that committed after the dump, and undo the transactions which are started but not completed. That is, it is same extended to allow the transaction to be active during the dump, known as fuzzy dump or an online dump. Sometimes what happens now in real-time applications, it's not possible to stop our processing. So in such cases, what we will do? We will extend this process, that is during the dump process also. That means during the process of dumping or during the process of fuzzy checkpointing introduction also, transactions are allowed. In such cases, we will call it as a fuzzy dump or an online dump. Like similar to fuzzy checkpointing, here also we can consider actually. So when we are considering this process, the entire recovery process is going to be depending upon the type of the failure, the recovery has been done by us. So recovery may be from the system failure or recovery may be in the disk failure. We addressed these two cases actually. If the recovery is in system failure and from the log files, from the checkpoints and fuzzy checkpoints, we can recover data. If the recovery is from the disk failure, then we have to consider the another word as a dump. By using the dump process, we are taking backup periodically. From that particular backup onwards, redone or undone process is going to be carried out actually. So, based upon these two kinds of failures, the recovery techniques are categorized warm restart and cold restart. That is depending upon the type of the failure. In case of system failure, we will call it as a recovery process a warm restart. In case of disk failure, we will call it as a cold restart. So what happens in the case of warm restart? In case of warm restart, first go backward through the warm restart means system failure. So first we have to go backward the log file until the most recent checkpoint recording the log file. So we have to move backward direction till we will get the recent checkpoint. And we have to set undo active transactions at the checkpoint. S of redo is initially empty, which was discussed. Just we are summarizing what we have done in previously. That means undo is going to be redo operations are done. We go forward through the log record by adding undo to the transactions with corresponding to the begin record and moving those to the commit record to the redo operations. So first we'll go through that. Whichever the transactions have both commit and start, begin and commit. Those transactions are under redo and begin and abort are also in the redo, and which are having only start without having any either abort or a commit are going to be in the undo list. So undo phase again, go backward through the log again, undo the transactions. Undo operation means replace each update with the old value and till the last checkpoint occurs. And also the transactions which are even before checkpoint also, which are transactions are started up to that particular TI start occurs. Redo phase means we go forward through the log again, redoing the transactions in the redo process. That means we are finding or we are checking two lists, undo list, redo list. Redo, we are redoing means each variable is going to be replaced with a new value. Undo means each variable is replaced with the attribute is replaced with the old value. The lists are going to be generated first, then these operations are going to be performed. We may be getting doubt. Multiple failures may occur. For example, failed now, again after some time again one more failure. Maybe it happens sometimes. Then what happens? Nothing will. These two operations or these two algorithms are known as atomic. Atomic means if you run n number of times, you will get the same output. These are the main characteristics of these two algorithms. That is redo operation as well as the undo operation. These two algorithms possessing the characteristic of atomicity. That means you run n number of times, but the output is. You observe here what we are doing. The values are there updated. In case of undo, we are replacing the variable value with the old value. And in case of redo, we are replacing with the new value. Because old value, new value are the same only, no? So if you run multiple times, the value will be the same actually. So in case of warm restart, already I explained one example. Another example we are taking B of T1, transaction T1 started, transaction T2 started, two transactions are there, you observe. T2 is updated, that is object 1 is updated with V1 old value, A1 with new value, and inserted, a new record is inserted in a transaction with the value 02 as A2. Okay. And B of T3 means third transaction started, and C of T1, transaction T1 is committed, and B of T4, fourth transaction started, and update T3 is updated. Here T3 is updated, and T4 again update. T4 is also some updation happened. Then T4 committed, T4 completed. After that, begin T5, T5 begin, updated T3, T5, some updation made in T3, T5, some deletion happened in our T3, then A of T3, that is T3 is aborted, and T5 is committed. Then we are having inserted data in our T2, T2 inserted. Some crash occurred, let us assume that. So if any crash occurred, we have to consider this checkpoint. Some checkpoint is there here, CK. This is the checkpoint represented, T2, T3, T4, some checkpoint. Where is this checkpoint? This checkpoint is occurred here. By the time checkpoint is there, T1 is completed. Before checkpoint, no need to consider more. Then T2, T3, T4, T5 is after checkpoint. While doing this process, what are the things are happening? T2 is continued. So because T2 know about or no commit is there, so T2 will be in the undo list. T3 started before, but it is aborted, so it can be in the undo list. And T4 is committed, completed, so it can be in your redo list also. When by the time crash occurs, T3, T4 completed, T5 completed, only T2 is going on, T3 is aborted. These two can be undone, and the remaining things are going to be redone actually. So this process is going to be continued. You observe T0, undo, T2, T3, T4. First initial list of undo list is 3, redo list is commit, see T4 occurred. So that's why from undo, T4 is removed, commit occurred, no. So we have to consider the process. T4, commit T4 is there after checkpoint. So initially, these are the list T2, T3, T4. Checkpoint is T2, T3, T4 are there still. Redo list is empty. Commit T4 occurred for us. So that's why from remove T4 from the undo list. What is undo list? T2, T3, and it is added to the redo list, committed now. Begin T5. Begin T5 means one more is added to undo list. T5 added to undo list. Redo remains. Then commit T5 is there. Commit T5 is there means our T5 is completed. So what we supposed to do? We have to consider the respective T5 is going to be removed from undo. It is added to the redo. Fine. Then whenever we are having these things, undo redo means respective T2 are going to be undone, T3 is going to be undone, T4 is going to be redone, T5 is going to be redone. Based upon that, these updations are going to be like this. D, where is going to be considered as a D06, O5, Object 5, Object 3, Object 2, Object 1 are there. You observe here, Object 6 is related to T2. T2 is under now with old value. So that's why object 6 is going to be having the value as a respective A8 only. And you can observe that we are adding, deleting 6, we are deleting, and respectively we are using actually. So based upon these undo transactions T2, T3, these whatever the object 5, object 3, object 2, object 1 are going to be having the respective old values. And these redo operations, based upon these redo operations, T4 and T5, object 3, object 4 are going to be updated with the new values. So this is related to our warm restart. And in case of any disk failure, cold restart is going to be considered. In case of cold restart, first we have to search most recent dump record in the log file, and the entire dump is going to be loaded into the secondary storage device to the buffer actually. Then we have to execute our recovery techniques from the dump state onwards. That is, we will reapply the actions in the log record in order to determine by the log file. At this point, we have the database state immediately before the crash. Then after crash, whatever the updations are there, those are going to be redone by using redo operation. We will execute this warm restart procedure on the dump so that the entire database is going to be taken back, and from the log records the data is going to be executed. This is an example of log records, dump, begin, etc. etc. This process is going to be redone based upon the dump data, and no need to have any undone operations actually, because the same process is going to be completely re-executed again. So we go to the most recent dump record in the log file and scan the log file forward starting from beginning of the transaction 1, and we will execute all actions in the log till the entire log record is going to be completed. That is C, commit of T7. We execute the warm restart procedure. That is, then we will execute the warm restart procedure. That is redone and undone operations actually. Thanks for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.